All right. You show up?
Yes, did.
All right, very good. Thank you, Romy, for that wonderful introduction. And I appreciate it very much. And I appreciate all you folks being here on Earth Day. And I find it an honor to be presenting at Glenview Public Library on Earth Day. I really do appreciate it and all the efforts that Romy went through to pull this together. I'd also like to thank Mr. Al Gore and the Climate Reality Project for all the support over the years as I've gone about making my presentations and learning what's what. I tend to like to start my presentations with this, frequently with this photo called Earthrise. This photo was taken by Apollo 8 after it rounded the moon, did not land, and was surprised by this image and just pulled out the Hasselblad and took it. It became in the day what you call viral, an incredibly popular image, inspired me and many other people. It just suggested the fragility, the small size of our planet, the finite nature of our existence, and actually helped launch the environmental movement we understand, and obviously the first Earth Day a year later. So it's an important picture for us. And although the greenhouse gases were not really a topic of the first Earth Day, as mostly water pollution, air pollution, it really is now. Because as a nation, since the first Earth Day, we've warmed almost 2.5 degrees. Chicago itself has warmed about a little over 1.5 degrees just since 1970, our first Earth Day. And once again, we have a phenomenal amount of climate disasters and billion-dollar events throughout the nation. This is 2020 summary, from firestorms on the West Coast to hail and rain and flooding in the Midwest, horrific tornadoes through the Central South, hail down in Texas, and of course, a myriad of hurricanes throughout the Southeast. Just another year in the era of climate change. After that first picture, 6 years later, this picture was taken by Apollo 17, the last of the Apollo missions. This was a stage photograph, and it was the first of its kind. It became the most published picture in the history of the world. Why? Because it's our home, and we recognize it as such. And people became affectionate toward it, if you will. But right now, our home has a climate crisis, the most serious challenge our humanity has ever faced, forcing us to consider 3 basic questions. Must we change? Can we change? And will we change? I'm going to try to answer these questions during this seminar. First, must we change? Now, be warned, there are disturbing images ahead, but all as predicted decades ago by scientists. We're talking about climate catastrophes. But stay in with us, because we end this on a very positive note, because there's some amazing things that are happening that will give you hope for the future. But first, in order to understand this topic, we must reacquaint ourselves with the greenhouse effect. Because as we know, our Earth is warmed by the sun through its radiation passing through our atmosphere. Some of this energy is radiated back into space in the form of infrared rays. But some of this infrared radiation is trapped by the natural level of greenhouse gases that have existed in our atmosphere since time began. But currently, we're spewing 110 million tons of man-made global warming pollution into this thin shell of an atmosphere every 24 hours, as if it were an open sewer. This is what this open sewer looks like. It's only 6 miles deep. In it is all our breathable air, and in it is trapped all of our pollution. And it's like we're performing a gigantic chemistry experiment in this very narrow band of atmosphere. by putting all these pollutants in it. And by doing that, we're adding more greenhouse gases, and thus we're retaining an additional small amount of heat, but just enough heat to throw off a lot of natural systems. This is global warming. This is the task that we have before us right now, this task for humanity. Where do these greenhouse gases come from, you might ask? Well, from all various aspects of our society, from our industries, from our homes, transportation and agriculture. Anything that burns fossil fuels generates greenhouse gases. And by far, the greatest source of greenhouse gases is the burning of fossil fuels for energy, which provides 80% of the world's energy. Right now, CO2 is being released into the atmosphere faster than any time in at least the last 66 million years. That seems a long time ago, and a lot of that data is proxy data, but actually we can go on the Antarctica continent, do ice cores and release gases that were trapped there hundreds of thousands of years ago and analyze them. And that's what we've done and represented on this graph. And as you can see, this represents our CO2 concentrations, and it's stayed in a very tight area from 280 to 180 parts per million for at least 800,000 years. We can use the same information to extrapolate the temperatures that existed in these various epochs as well. And as you can see, temperature and CO2 concentrations go together. When one goes up, the other goes up, and vice versa. They're like bread and crust, they cannot be separated. And as you can see how sensitive our climate is, when the CO2 levels and temperature dipped a little bit below the average, it was enough to tip our climate into ice ages. So think about that when we talk about increased temperatures and what that may do. Just for note here, the average concentration of CO2 during this period was 230 parts per million. Now, I'm sure you're anxious to know where we are today. Well, when you find out, you may not be. Because as of today, we are over 420 parts per million. We're on our way to doubling our CO2 concentrations of the last nearly million years. Scientists have spent a lot of time trying to figure out where we're headed. And if we continue to consume energy at the rate that we are, in the manner that we are from fossil fuels, in 40 more years, we'll be easily at 600 parts per million, which would be a catastrophe for the human species. Now, and keep knowing that this is CO2. Temperature is bound to follow. It's just physics. And it's already showing up. 19 of the 20th hottest years on record have all occurred this century. And the 5 hottest years, not by coincidence, occurred in the last 5 years. Now, this is another way of looking at it, with this chart showing the year-by-year accumulation of greenhouse gases. And you can see it's centered on some of my images here are in the way. I don't know if you want to shut off my pictures there, but the greenhouse gases continue to go up. It was predicted when the slide was created last summer that there was 72% chance 2020 would be the hottest year ever. Well, the scientists again were right. It actually tied for the hottest year ever. So the heat goes on. And this in spite of the fact that we had a La Nina present for most of the past year, a climatic cooling of the ocean off the West Coast that tends to cool the atmosphere, especially in the United States. Now, for the purpose of this presentation, I'm only going to use observational evidence over the last 2 or 3 years because there is enough of it to use as examples. So let's start here by talking about 2018, where there are 224 all-time records set for heat. Now, one in particular one I'd like to highlight here And that was the hottest overnight temperature ever recorded, 109 degrees almost. Now, this proves to our way of thinking that it's not the sun that's doing this. It's not sunlight directly. This happened at night. This is the greenhouse effect continuing to radiate. And we have a greenhouse effect that's getting overheated. 2019 was another bad year. Europe's hottest year on record. Numerous countries in the European continent achieved their all-time temperature records. I'll highlight one here, which is France, because they broke their all-time record by a full 2 degrees, 115 degrees in June in Paris. Melbourne, Australia, earlier that year suffered 121 degrees. And that's in southern Australia. That's the furthest away from the equator. Miami recorded their hottest week ever last year as well. Several African countries, including Ghana, set their all-time temperature records as well during 2020. And of course, Australia, which has suffered so many heat waves, had another one early in that year. But if you really want to see where the temperatures are changing the most rapidly, it's in the Arctic of all things. Now, this is a floating Arctic ice sheet, and this is Greenland. This is land-based ice. We'll talk about that in a minute. But the Arctic is heating 3 times faster than any other place on the planet. And the reason is since the last ice age at least, the sun's rays have bounced off the white surface of the polar cap, harmlessly going off into space for thousands of years. But as the climate warms, water warms, air warms, the ice shrinks, revealing dark water. The dark water conversely absorbs the energy from the sun, as well as the darker land as the snow melts there. So at this point, we're creating a heat sink in the Arctic. Now, this can have nothing but detrimental effects to our climate, because one of the main functions of our climate is to be a heat exchanger. It takes the water and air that accumulates around the equatorial region and circulates it north and south, as all natural systems do, to even out its heat. Now, our Earth uses an ancient series of air patterns and water currents to do this circulation and cool itself off. But if we're going to look at some increasing temperatures here, including 3 times the amount up at the Arctic, what is this going to do? This is going to change these current and wind patterns in ways that we cannot predict. And keep in mind, our civilizations were literally created based on these predictable patterns for agriculture and ports and all sorts of things. And we throw it all into question. These are going to change. And I'm going to show you some examples because they already are. You're familiar with the term polar vortex. We've got to know it recently because of some of these changes. The stable polar vortex, which has been through most of our lifetime, has been fairly tight in the wintertime, containing most of the cold air far north. But of late, with the heating of the Arctic, it's released this cold air pocket, and the jet streams are starting to become wobbly. And this is allowing warm air to move north to the pole and cold air to come down and make us frigid. And you've seen a lot of these examples. Now, this is some incredible photography showing a perfect normal jet stream, which we've probably had most of our lifetimes, and occasionally now. See the tight circle there? This is the new normal. See it's a coherent jet stream. It does connect in a loose circle, but it's very wobbly. And this is generally what we're seeing in the wintertime looking down from the North Pole. And what's happening, such as what happened in mid-February, frequently stratospheric warming will come in and push and split these polar vortexes and push them around. It split it in 2 in February of 2018. First time we've noticed that. And here is that image from that exact same day. And you can see the warmth coming streaming up to the North Pole as the cold descends on the other hand. As a result, temperatures of the North Pole that day was 50 degrees above normal. So even in winter, the ice was melting at the North Pole. And that same day, it was snowing in Rome. Yes, our weather is getting wacky. And this is not just one-off anomalies. These polar heat waves have occurred in 16, 17, 18. In 19, we had a different effect. Not as much warm air made it to the pole, but the polar vortex split into thirds, which we never anticipated. And here's what that looked like. And here's what the graphic representation of what that did. The cold air flooded down into our breadbasket in Midwest here. That day, here's a picture of Chicago that very day. It was frigid. But let's make this bring this totally up to date for a second and talk about that Texas cold weather debacle that we recently experienced. And you can see here, taken on that day, the cold air centered here all the way down to the Mexican border. But look up north. It's all way above normal. This is backwards. This shouldn't be, but this is our new reality, including later on in the summer, a temperature of 100 degrees north of the Arctic Circle. The first time in the era of the thermometer that's been reached. It's extremely troubling to climate scientists and should be to all of us, because as a result of this, Arctic sea ice extent is just evaporating, and only rapidly. Now let's look at Greenland. That the ice on the Arctic pole is floating ice. When it melts, it doesn't add to our ocean levels. But Greenland is land-based ice. And when it melts, the water that comes off from that increases our sea levels. And boy, has it been melting. Matter of fact, one day in 2019, 60% of the surface of this immense land was melting, a rate of 10 billion tons of ice in a single day. And all that water went right into raising our sea levels. And this has not been, this has been a long-term issue in Greenland. This is what a glacier looked like 1935, pretty typical for glaciers. That same glacier more recently in 2013. It's liquefied. Glaciers all over the world, and of course, Greenland, are in vast retreat. The declining ice mass is significant, every bit as much as in the North Pole itself. But if we really have to look where the ice and water is, you have to look at Antarctica. Now, Antarctica is cold for two reasons. First, it's on the South Pole. But second, it's got most of the land is very highly elevated, 5,000 to 10,000 feet, which is cold by itself. For this reason, scientists did not think it would be so affected, at least not early in the development of the global warming phenomena. But that's mainly because we didn't have enough instruments on the darn place. And now the study of it's very important because 90% of all the ice in the world is contained here, as well as 70% of all the fresh water. And now that we have more instruments in place, especially in this West Coast, this very unattainable area, finding out that on average, it is melting, especially on this West area, which if this entire area melted, would add 20 feet to our world's oceans. So the scientists were too optimistic, and now we're being more realistic. Is it changing our ocean levels already, all this melting ice? Well, we're getting, in the United States, for instance, we're getting a doubling the frequency of high tide flooding. Now, cities were built along the coast to accommodate a normal high tide. But now we're finding out that that infrastructure is not adequate given the ocean levels are too high and high tides are just higher. Now, what does that have to do with this octopus in the middle of a parking garage in Miami? Well, Miami's got a different problem. They're built on old coral reefs, which means that this is limestone, and limestone is porous. So unlike most cities, they can't build seawalls to keep the sea out. The sea just penetrates the land and percolates up from beneath it. And that's what happened to this guy. There's a little sewer over here, and he was forced up by these increasing ocean levels, and that's where he ended up. But this doesn't portend well for Miami. It is the city most at risk in terms of assets from sea level rise in the world. Notice New York is number 3, and all the other cities are in Asia. Many people feel that the city of Miami itself is probably doomed for this unique geography that they have. But let's go back to a world perspective here for a second and say and tell you that most of the heat that has been increasing over the last few decades has been absorbed by our ocean, which is, we really didn't expect that, but it has happened. So it's a little easier on our skin temperature, but what goes on in the ocean doesn't stay in the ocean, for all due regard to Las Vegas. And you can see here too a similar graph showing that ocean temperatures, much like the land air temperatures, have been on a steady incline. And again, the prediction was we made in the middle of last year, we're going to see a record again, and this time they were right. A new record was established for the thermometric record. This is, by the way, I did mention this before, this line is the 20th century average here for both these types of graphs. So you can see how much above average we are. And the ocean is heating up. And it's not just at the surface where you'd expect this. This heating is going on all the way down 2,000 meters and more, changing the biology and the chemistry of our oceans. And unfortunately, half of this heating has all occurred just in the last 20 years. So this is going to be a problem that we're going to have to deal with, because our species cannot live with a dead ocean. But like I say, what goes in the ocean expresses itself later, doesn't stay there. And as you know, hurricanes are fed by hot ocean water. But let's look at the path of Hurricane Harvey, one of the worst storms ever to hit the Houston area. And it accelerated very rapidly because over the Gulf of Mexico is 7 degrees hotter than normal. And it proceeded to go make landfill, but then it ran into one of these wobbly jet streams, and it bounced back, and it bounced in, and it got regenerated, and then it came in again. And as a result, it stayed around for a week, creating a 10,000-year rainfall event in the Houston area. Some areas got excess of 40 inches of rain. It was a disaster for that area. But many of the other hurricanes of late have shown similar tendencies. They accelerate rapidly before they hit land, which is unusual, and then they stick around and they don't move. This was only a Category 1 storm. It dumped 20 inches of rain in South Carolina and stayed there again for days. They don't move through like they used to. Remember, more recently, Hurricane Dorian, the most powerful storm ever to make landfall in the Atlantic Ocean. And it hit the Bahamas hard, especially Abaco Island, where it stayed for 40 straight hours at 180 miles an hour, 60 inches of rain. I do not think this island will ever recover. But the very next year, we saw, when I was looking for Hurricane Sally, and this image came up, 6 simultaneous circulating storms in our oceans in the Northern Hemisphere at once. The first time in the satellite era that an image such as this was able to be taken. 2020 was the most active hurricane season on record, with storms flying all over the Atlantic. 30 named storms, 12 made landfall in the US, 13 hurricanes, 6 were major, the 50th consecutive above average season. We literally ran out of letters of the alphabet to name them. We ended up going to the Greek alphabet, and the last hurricane was Iota. What is happening? We are energizing our hydrological cycle, the thing you studied in 7th grade science class. We have evaporation over our oceans. Now, much more heat, makes more water evaporate. There's now 4% more water vapor over the oceans than just 30 years ago. This leads to increased precipitation as rainfall and snow. And then obviously when the snow melts and the rain flows into our streams and rivers, it all ends up in the ocean. And again, since this is coming off of land, we raise our ocean levels. The flooding in the Midwest has been horrific for years, but more so lately. And some of these, the rainfall is just excessive. And here, this is a picture of Pacific Junction, Iowa, several months before their spring inundation. And this rainfall was very regional, and it separated farmers from their crops, people from their homes, and the governor actually refused to declare a state of emergency until it was actually way too late. Didn't want the bad publicity we hear, but we're not really sure why. Nebraska, they had no trouble declaring states of emergency in 2/3 of Nebraska's counties in 2019. In total, the U.S. incurred $20 billion in flood damages in the Midwest, including $6.5 billion in federal crop insurance. But this is not just a U.S. problem, as you would expect. This is a global problem, and you can see the anomalies packing up on the right, just as in the previous graphs. These record-breaking precipitation anomalies are incredibly widespread. Here's some examples. In Kumatown, Japan, 44 people were killed in torrential rain and mudslides last year in the summer. Around the same time, flooding in this province in China killed 63 people, caused nearly $3 billion in damages. And get this, in Guadalajara, Mexico in June, over 5 feet of hail fell overnight. Our weather is messed up. And don't think the insurance companies haven't realized this. They are paying so many insurance claims due to extreme weather catastrophes. Munich Re, one of the largest insurers, has created and maintains this graph just to show how their claims experience has been. If your property insurance is going up, even here in the Midwest, this might be some of the reason. Even Noah's Ark, the replica created in Kentucky, seems that it wasn't built quite to specifications because it too incurred rain damage up to $1 million they had to sue for. I guess the insurance company couldn't believe the ark couldn't float. But there we are, adding that million to the $650 billion in extreme weather costs just over the last 2 years. When people say we don't have enough money to clean up our energy grid, then look at what we're losing because we haven't done it. But this is one concept that we have to cover here, and that is that the same heat that generates more evaporation and more rainfall also extracts more moisture from areas prone to drought. So global warming causes both more rainfall and more drought. Some sort of hard thing to get your mind around, but this graph does a pretty good job of explaining why. And the U.S. government maintains a drought monitor, and here's the latest one I could find for what's going on in our country. And it's been a persistent drought in the Southwest now for years and years and years. But it's even worse elsewhere. This is Chennai's water reservoir. The 6th largest city is nearly out of water. And when that happens, the only way you get water is to walk it back to your home. You can imagine the time and misery of having to do this every single day. This drought is the worst in living memory for the people of Chennai. And in the western Cape Province, where Cape Town is, the most vibrant city in maybe all of Africa, and it literally almost had to shut off the taps in 2018 because their reservoirs dried up as well. Iran, we don't have a lot of great information on, but they have been suffering through drought incessantly now for maybe as much as a decade. New South Wales in 2018 had the worst drought in living memory. And you know what happens after the drought? The fires. And the Australian drought spawned amazing amounts of fire. We remember it last January of 2020. Now, these fires just consumed thousands of structures and homes, charred as much land as the size of the state of Kentucky. Over 20 people were dead and thousands were made homeless. But we tend to remember the animals now, don't we? Because their images are so compelling. And these unique animals on this continent took a beating. Estimates say over 1 billion animals were killed. Many were rare species that may not have enough population now to maintain their numbers. It was literally a tragedy. And what did it take to put out the fires? Another climatic calamity, nearly. 8 inches of rain in 24 hours, one of the heaviest rainfalls they've ever had. And yet it was welcome because it put out these fires, because humans really weren't going to be able to do it by themselves. Now, as we know, here in the United States, we have a lot of problems with fires. As the temperature goes up, there's a direct correlation. Fires go up. Temperature drops, fires drop as well. But right now, the fire season in the Western states is 105 days longer than it was just in 1970. And California has literally been on fire in recent years. Every single year, they get major fires. The 3 most expensive wildfires in history have all happened the last 3 years in California. I included this image from the Presidential Library and the Reagan Library to show you how these fires look. They're long, linear fires. They get very difficult to fight. They can difficult to contain, and they're dealing with this every single year. Since 1972, the average area burned in California has increased 500%. California fires are an ever-repeating tragedy, year in and year out. But it's not just there. Last year, Arizona, the wildfires burned hundreds of square miles throughout Arizona. In many counties in Florida, including Santa Rosa, thousands have been evacuated, dozens made homeless, trying to get out of the way of wildfires throughout that state. Previous year, an estimated 29 million acres of forest burned in Russia, leading to a state of emergency nationwide. And those fires continue over into the next spring, and I'll explain why in a second. Over 5 million acres were consumed, mostly in Siberia this time. But notice, this is the Arctic Circle. Many of these fires are occurring north of the Arctic Circle. This is new. This didn't used to happen. And unfortunately, the boreal forests that exist there are now carbon sinks. But as they burn, they become carbon emitters and change their function. And it's already happening because just in June 2020, the fires in the Arctic released more CO2 than Norway's entire annual carbon emissions. And in Russia, they suffer these zombie fires that can smolder like the one I just described. They can smolder underground in peat and then reappear in the spring. So they just tend to not go away. This brings to mind when in 2010, when a similar event happened. These were the peat bogs and fields closest to Moscow. And they all caught fire, and they were mostly underground, but they released amazing amounts of toxic gases. These gases, not the fires, killed 55,000 people. Now, this charred their farmlands greatly. And 4 months later, world food prices reached a record after Russia halted their grain exports, and Ukraine followed quickly. Now, we have to realize that these food prices affect the entire world and can lead to serious geopolitical consequences. There, after all, were food riots in 60 countries during this time. You may remember one such incident in Tunis, Tunisia, where a food cart operator burned himself alive in a public square. His last words were not death to the tyrant. His last words were, "How am I to live?" because he couldn't get enough food to sell in his cart, let alone feed his family. Many people say that the Arab Spring began with that event, and I wouldn't deny that, but it does bring to mind a farmer, Ahmed Abdullah, that we've profiled here in these presentations recently. He used to have 400 acres of wheat that have now become a desert. In 2010, he lost it. He lost all his farm animals, and he had to, as the drought that started in 2006 turned 60% of Syria's fertile land into desert and killed 90% of their farm animals. And Mr. Abdullah had to take his family and join 1.5 other million people who moved into Syria's already overcrowded cities. And what happened shortly thereafter? The Syrian Civil War, because there's too many people with nothing to do and no way to support them. The Department of Defense has been pretty prescient on this, though, and they realize that their mission is probably going to be changing, because now the conflicts are going to result from food and water shortages, pandemic disease, refugees, and battles over resources and natural disasters. Sounds very prescient, doesn't it? And it was the very next year we had the refugee crisis in Europe, where people were leaving war-torn Syria and the other areas of the Middle East that are suffering from drought, just to get out of there so they can get food and water. But this leads to geopolitical problems, because the blowback was horrific. This is a photoshopped image that made a billboard in Britain, and it was probably the most effective advertising to the Brexit movement. And shortly after this crisis, they voted to leave the European Union to prevent something like this imagined influx from happening. But we're also getting demagogued here with these caravans, they call them, moving up from, not from Mexico, but to our southern border from Central America. Why Central America? Well, unfortunately, what's being created recently is a dry corridor in many of these nations in Central America, generating the refugees. El Salvador, Honduras, Nicaragua, Guatemala are in incredible drought. The crops are dying, and they're literally struggling to find potable water. And this was not a surprise, because for years, Honduras was ranked the #1 country in the world at risk from climate change. And Nicaragua was ranked #4. And the scientists were right. It is happening. But the people are moving here because they don't have anything to eat due to this tremendous climate instability. It's radically changing food security in the region. So we know that climate can affect our food supply from examples such as this in many interrelated ways. Some are very obvious, but let me just talk about a couple here, because that's all that I don't have a whole lot of time. Let's talk about heat. Much of our crops were selected and nurtured by Stone Age women who developed crops that would survive and thrive in the climate that they had. Now it's hotter, and some of these very species of plant can't thrive in these climates anymore. And we're finding out how sensitive some of these crops are to heat. As a matter of fact, for these important crops, for each 1 degree increase centigrade of warming, the projected yield for corn, wheat, and rice, and soy dropped precipitously. And these crops make up 2/3 of our human caloric intake. And the heat does that. But it also provides a double whammy: nutrition. In these same crops, they use so much of their own nutrition to fight back at the carbonization of the atmosphere, the excess CO2, and the heat, that they consume a lot of the nutrients before they're harvested. As a result, we're getting both lower yields, and the yields have less nutritional value. This is what heat will do to our agriculture and our food supplies. But climate change is also a medical emergency, as the Lancet has been warning us for many years now. So how does climate change affect public health? Well, it's similarly interconnected in a myriad of ways. Why don't I talk about just a couple here that maybe have the most impact? One is heat stress. And heat stress generally affects the most vulnerable in our populations, the poor, the homeless, children and infants, elderly, mentally ill, agricultural workers, and people with pre-existing conditions are most vulnerable to these heat events. And this is not merely some third world problem. Extreme heat events cause more deaths annually in the US than all other extreme weather events combined. This excess heat also increases allergens in our atmosphere. Matter of fact, the pollen content per cubic meter will double, even triple over the next few decades, which is not good news to anybody in your family that suffers from hay fever. But this is the future that we're creating for ourselves. Air pollution is the biggest killer. And air pollution, as we define it, is the pollution from the burning of fossil fuels, because it creates a pollution that's heavy in particulate matter. Worldwide, this air pollution kills 9 million people every year. There's not one nation in the world that is not suffering to some extent from population dying or becoming very ill due to air pollution. For instance, in India, in 2017, roughly 1.25 million people died from air pollution causes, which represented 13% of all the deaths in the country. A baby in Warsaw will inhale the equivalent of 1,000 cigarettes in its first year of life because of the air pollution and smog in the city's environment. And here in the United States, more than 40% of people in the US live in counties that don't meet EPA air standards. Who are these people? We know they're the people who of limited means, little political clout, the poor, minorities, and people of color. So it shouldn't be surprising that overall African Americans are 3 times more likely to die from particulate air pollution as the overall population, because they're forced to live in these areas near the factories and where the pollution is high. So this is by definition an environmental injustice problem. So as we solve the climate problem, we must also coincidentally solve this problem as well and make sure we don't prolong this environmental injustice. Because we've learned a lot about air pollution over the years. We've been studying it for a long time. As a matter of fact, during the last pandemic, which we've learned a lot about, suffering through this one, they found that coal pollution, cities with high coal pollution, saw 10% higher mortality rates. Recent studies in China have confirmed this and found a 15 to 22% increase in COVID cases in cities with elevated levels of nitrous oxide and particulate matter pollution. So these studies keep putting out the same results and the same effects. Death rate from Americans from COVID was more than twice that of white Americans. And we feel that much of it had to do with the air that they breathe. And of course, infectious diseases, which we always worry about, especially of late. But climate change is making natural ecosystems much more tolerant of these diseases, and it makes life better for them, because the vectors that pass them on, the mosquitoes and the ticks, find, as they begin their voyage from the tropics, they find very hospitable environments. Now, of course, air travel has made these expand greatly, but it's just that when these disease vectors do end up in Denver or somewhere, they find a very hospitable, warm, wet environment for them. So it's not surprising that tick-borne diseases more than doubled in this country between 2004 and 2016, and mosquito-borne infections increased nearly 10 times. These vectors are finding a home up north and way down south. As the climate changes, and this is quite topical for today, we expand further into Earth's remaining wild places and come in contact with wild animals. In coincidentally, 5 new infectious diseases are emerging on average each and every year. 75% of these infectious diseases are zoonotic, meaning they are transmitted from animals to humans, much as we believe now COVID-19 was. The climate change also increases the risk of many waterborne infectious diseases, such as these. Now, here in the US, our water systems are pretty good and we don't get these normally, but when we have a extreme precipitation event, more than 2/3 of the waterborne disease outbreaks have occurred during these events. So we're not immune from them either. And the toxicity is not just limited to land, but the highly toxic red tide in Florida and other locations around the world releases toxins in the water that kills fish, manatees, sea turtles, and sharks. And because the toxins also are present in the air from the red tide, it prevents people from literally visiting the beach. You cannot breathe the air there, which has been a huge impact on tourism in Florida and other states in the southeast part of our country. And this is all contributing to an overall trend here. The population of marine vertebrates is declining about 50% on average since 1970 for all vertebrate species. Now, a lot of this is from overfishing, but ocean acidification and ocean temperature increases and toxic algae blooms are the result of climate change, and that's having a huge impact on these species as well. As a matter of fact, we're now at risk of losing up to 50% of all land-based species if we let that carbon content go up to like 600 parts per million. These animals will have no place to go. So quickly, I have gone through a lot of the costs of carbon, as we call it, tried to highlight as many as we could. But there's one that needs to be emphasized here because it is the number one threat to the global economy, according to the World Economic Forum, is climate change. Because besides the widespread destruction and infrastructure loss, climate crisis is becoming a financial crisis as well. Let's just look at one at-risk industry. Governor of the Bank of England said the vast majority of carbon, meaning coal and oil reserves, are unburnable in order if we're going to save the planet. Mr. Gore took this and created his concept of a subprime carbon bubble, which he explains in this way. This circle represents all the fossil fuels burned from the discovery of oil to 2010. And that was the amount burned in the 10 years preceding 2010. This large circle represents the remaining proven fossil fuel reserves. All of these reserves are on the books of oil and gas companies throughout the world and sovereign gas companies and oil companies as well. This is the amount that's burnable if we're going to keep our heat increase to less than 2 degrees centigrade. That means that there's unburnable assets worth $2 trillion that'll have to be left in the ground if we are to save this planet. And that is a hard mountain to climb. This is why they fight so hard. But they're now realizing. The BP's head of strategy said, unextracted resources we own, many won't see the light of day. Because right now we might actually, we've heard of peak oil demand. I think we may have reached it. Now, we've been predicting it for a while, but now seems to be what's happening. Now let's describe exactly what peak demand means. An incumbent technology, this time fossil fuels, makes predictions based on past sales and projections as to how many assets they have to acquire to support their sales going on in the future. And oil companies have to acquire a lot of assets. But when a challenging emerging technology comes on, it can throw those sales forecasts out the window and leave companies like these with stranded assets. And these are a burden on them and the rest of us, really, because all these companies had to do major write-downs to accommodate the fact that their reserves are no longer worth what they thought they were and maybe have to be left underground. Now, if you follow the stock market, you realize that since 2010, the S&P has done just terrific as a whole. But one section that hasn't done well at all, the worst performing sector, the energy sector, comprised of mostly oil and gas companies. It just didn't participate in this bull market. Since Trump took office, clean energy companies have increased their sales considerably and their equity. Fossil fuel companies gone the opposite direction. And this is with a supportive president to the oil companies, Trump, in office. Why is this happening? Because we over-subsidize fossil fuels. Worldwide, trillions are going to subsidize fossil fuels versus billions into renewables. 36 times more worldwide do we subsidize oil and gas compared to renewables. In this country, we're not much better. Here, we also subsidize oil and gas to a great extent, 24 times more than renewables. This is backwards. This has to change. This is insanity. We're back in the wrong horse. So must we change? Yes, we must. The next question is, can we change? And oh yeah, I know. I think we can, because we're doing it already. We're not destined to follow the residents of Easter Island that scientists have told us consumed all of their natural resources and made themselves extinct, leaving just these markers behind, because we, unlike they, have solutions at hand. They first start with understanding which energy sources are the most efficient for not utilizing and putting CO2 in the atmosphere. And you can see their wind, solar, and geothermal are easily the best choices. And coal, a horrible choice, and natural gas, about half as bad as coal. So as a result, the world is making choices. Global wind installed capacity is surging throughout the world at an exponential rate of increase. Here in the United States, our wind energy capacity is on a similar arc, going nearly straight up. And as you would expect from economies of scale in a market economy, our offshore wind costs are dropping precipitously as you install more and more of these systems. That's just economics. That's how it's supposed to work. Our solar picture is even brighter. Solar photovoltaic installations worldwide have even a sharper arc up, as is the US solar photovoltaic capacity. It is going up nearly at an exponential pace. And as you would expect, the cost of the underlying silicone and the products that go into it is dropping precipitously. So now what used to cost us $80 a watt to generate solar now costs us less than a quarter. Now, these economies of scale are paying off. Renewables produced 56% of Germany's electricity in the first half of last year. In England, which has always been very coal dependent, they generated 18 times as much electricity from renewables as from coal in 2019. Now, this is interesting because back in the 50s, during the rebuild after the war, they were worried in Britain if they had enough coal to fund their rebuilding of their economy. Now, the record is they have too much coal. They're not using it anymore. See how things can change. And here in the US, our coal consumption is dropping. And as you would expect, what's replacing it? Renewables. So what we have is a old technology, coal, that's on its way out. All of these represent proposed coal-fired energy plants proposed between 2005 and 2017 and defeated by either popular referendum or public utility boards. These were existing plants that were retired during these years. And these were plants that announced their retirement. Well, this might be the good part of cancel culture because we are canceling coal as an energy source, but we're not doing it for any other reason than it makes economic sense, as well as sense for to save our planet. U.S. coal consumption is now at a lower, as low as it has not been this low since 1978. Let's give an example. Northern Indiana Public Service currently produces about 2/3 of its electricity from coal. It announced it's closing all its coal plants by the end of this decade, converting to solar and wind to save its customers more than $4 billion. This is a trend. And I always like to come back to Kentucky for irony. Here's the Kentucky Coal Museum there, who's very quietly on the top of their roof installing solar panels to save their museum $8,000 to $10,000 per year. But no one's supposed to know that. But no one knows that 2/3 of our global population now live in countries where solar and wind are the cheapest source of new bulk energy generation. But the key to sources being viable and replacing fossil fuels is storage. And here is another industry that's on the verge of a massive breakout. Energy storage deployments, in other words, big batteries, have doubled each of the last 3 years. I don't have the data for 2020 yet, and are projected to increase in a huge manner over the next few decades. Because the sun isn't always shining and the wind isn't always blowing, we have to store that energy that's generated. And as you would expect, as these batteries are more and more deployed, the cost keeps dropping. Again, the economies of scale has allowed Tesla to build the world's largest lithium-ion battery and a wind farm in South Australia. Not to be outdone, Florida Power and Light just announced it will replace 2 natural gas-fired plants with solar farms and a new battery system 4 times larger than the one I just described in Australia. Folks, we are now entering another societal revolution. The first one was the agricultural revolution. The next, the industrial revolution, a couple hundred years ago. The agriculture about 8,000 to 10,000 years ago. The digital revolution, much more recent. Now we're entering the sustainability revolution, where we reorganize our economy around new forms of zero-emission energy done in a healthy, equitable way with sustainable growth. And this change will hit us with the magnitude of the industrial revolution and the speed of the digital revolution, and become the biggest new business opportunity in the history of the world, and is the greatest way to create new jobs. And we do not feel we are exaggerating in this prediction, but we have to take care of the workers who will be displaced. This is an important part of this revolution. The European Commission has budgeted approximately 44 billion euros to transition workers from the carbon-related industries to the new industries. In the United States, this could be done much cheaper. For a mere $2 billion, we could retrain the vast majority of coal workers into new jobs in solar and wind. What a bargain. And this is where they need to go, because there are nearly 5 times as many jobs in solar now as there are in coal mining. Over the last 5 years, solar energy jobs have grown 6 times faster than overall job growth in the economy. And now we've turned there's now been a political sea change, where more than 70% of US voters support 100% of their electricity in their state coming from wind and solar by the middle of this century. In this area, bulk electric generation, we've been making terrific progress. That leaves us with transportation, which in this country and many other countries in the world is now the biggest generator of CO2 emissions. And we have to do something about transportation. And this is LA, day before Thanksgiving. You thought traffic in Chicago could be bad, but this is horrific. All these cars emitting massive amounts of CO2. But we have a savior, and that is the electric car. And with batteries cheaper, electric car sales have surged. And as we can expect, even efficient fossil fuel powered cars, their costs will continue to increase as they have for years. But the mainstream battery electric car prices have been dropping, and they will reach cost parity just in a couple of years. And when it's cheaper to buy an electric car than a fossil fuel car, that's going to be the preferred mode of transportation. Many European cities have figured this out and are announcing bans on internal combustion engines to take effect over the next decade. Many countries as well have done the same thing, phasing out fossil fuel vehicles nationwide from 2025, maybe just as far down as 2040. But they're making the move, and that has spurred companies like General Motors to believe, as they say, the future is all electric. And right now, General Motors is building 2 massive battery plants in Ohio and in Texas, or excuse me, in Tennessee, I think the other one is. And he's going to announce 20 to 30 electric models. Right now, there's 11 million people work directly or indirectly in the renewable energy sector. And as these industries transition, even more will be working in this sector. The solar installer is forecast to be the fastest growing job category in the US for the next 5 years. The number 2 category, wind service technicians. These are the jobs of the future. So can we change? Yes, we already in many ways are. But here's the million-dollar question. Will we change? Well, we're optimistic because, for instance, Norway's sovereign wealth fund began divesting its oil and gas investments. And Norway is a huge oil and gas provider. Wall Street is getting it. One Wall Street firm says that innovation in global markets are going to be the primary driver of change to batteries and solar panels and EVs and wind. And it's the market themselves and the economies that are creating this push. And it really, they say, is not dependent on who occupies the White House. Well, that's Goldman Sachs. I'm not as sanguine about who would occupy the White House, but a lot of the results that I've showed occurred while Trump was in the White House. So having a supportive president would make the change happen even faster. Right now, many states and territories are announcing ambitious plans to use entirely clean electricity by 2050 at the latest. 112 financial institutions have announced they will stop financing coal-fired power plants. And look at this. Over 250 or nearly 250 global companies have made a commitment to go 100% renewable in the next few decades. These are those companies, some of the biggest companies in the world. But it's not just these few hundred companies. It's because each of these companies has a supply chain of dozens, if not hundreds of companies. And they're now negotiating clean energy purchase agreements with these suppliers in order to meet these goals. So they're driving the change down their supply chain. So it's going to involve thousands of companies getting the message and turning to clean energy. Now, it's not just the economics that's dictating this, it's the people. This is the crowd that attended the last global summit in 2014 in the UN on climate. People all over the world are pushing their governments. They see what we talk about here today. They see what the future is. And these governments have been responding. Matter of fact, in 2015, every nation in the world agreed at Paris to work together to achieve net zero greenhouse gas emissions by mid-century. How is that possible? We can't agree on anything in all these nations, yet we made this agreement. Now, many of you know that after the election, it was possible for the president to pull out, and Trump did. But as soon as Mr. Biden took office, the president undid it. And we are back in the Paris Agreement. And today and tomorrow, he's leading Zoom and virtual conferences with other world leaders, trying to reassume American leadership in this field. Now, don't be confused by people who say we're getting fleeced and that countries like India and China are just laughing at us as we make these agreements. No, they're both on track to overachieve their Paris commitments. This is a fact. We must resist going forward. What? Resist the inertia of the status quo and resist the unscientific answers of the polluters and those making excuses for them. We must stick to the science, and we must look positively to the future. We want you to use your choices, your votes, to fight the climate crisis. So please use your voices, your votes, and your choices to take action now, and be willing to speak truth to power, like your world depends on it, because in reality, it actually does. Thank you very much. I appreciate your time.
Thank you so much, Kent. That was really powerful. At this time, I'm going to open it up to chat. So we do have one question so far. Goals to reduce CO2 emissions. Reducing doesn't eliminate. How is existing CO2 in the atmosphere reduced?
Well, first off, I'd like to make sure everybody has my email address here, because if I don't get to your questions, you can email me and I'll communicate with you directly. Maybe you set up a presentation. I do these for free, solicit printouts, or just make a comment. I'll be happy to correspond. All right, so I just wanted to add that. Now, the question was about how do we decarbonize the atmosphere? How do we remove the CO2?
Yes, how is existing CO2 in the atmosphere reduced?
Existing CO2, unfortunately, takes decades, if not centuries, to reduce. This is the sad legacy that we have. We won't see a great reduction in the CO2. All we're trying to do is prevent an increase in it. There are some technology alternatives being talked about, especially by the oil and gas company. It's got an interest in trying to figure out how to remove the CO2 they're putting in the atmosphere, of literally sucking CO2 out of the atmosphere and burying it in the ground. These are very ambitious geoengineering technologies. That's about the only one that I would give any credence to, because some of the other ones, like putting iron filings in the ocean and putting particulate matter in the atmosphere to block the sun, there's just too many variables, things that could go wrong. If we could figure out a way to literally suck out CO2, that would be a game changer, but we're far, far from it. And it's such a trace. I mean, we're only talking about 400 parts per million. So you have to suck in a lot of air to get a decent amount of CO2. I can't list a particular company that's doing this. I've seen them talking about it in the press. But unfortunately, CO2 is persistent. And methane up there is even more persistent. So it's we have to stop digging. We have to stop digging the hole that we're going into. That's the important thing. After that, we can start to figure a way to climb out of it. That's the best answer I can give you to that.
I have a question for you. So from an individual basis, I know a lot of this change has to come from the top and comes from your vote. But individually, what do you think is the biggest thing that you can do to help? My brother-in-law seems to think it's reducing meat consumption. Do you agree with that?
I think it's a very good one, because the production of livestock increases our methane in the atmosphere, and methane is 20 times more powerful a greenhouse gas as CO2. And after a few decades, methane then converts to CO2 in the atmosphere. So it really is a persistent chemical that we or molecule that we have to eliminate up there. And cows and cattle generate enormous amounts of methane. So that is a outstanding suggestion, reducing your meat consumption. I'm a carnivore. Many of my friends in this movement are vegetarians and even vegans. So I'm kind of the rarity. So I can identify with people who like their meat. But what I found is it's so easy to cut your meat consumption in half. Portion size means a lot. And as a family, I know we just from portion size, we have cut our consumption of red meat down probably by 2/3. And I really haven't noticed the loss. I still can have my steak on occasion. Other important things that you might be able to do right now is elect the right politicians, both locally and state and nationally, because this effort is beyond just what individuals can do. We have to have the governments involved in helping us make this transition. You have your personal habits. I don't know if you see this on the screen. I've got a what I can do flyer. I can send this out to you, but to people who write me. But you know, in there we suggest using limit use of disposables, use native plants in your yard, ensure your house is properly insulated. That can save you a tremendous amount of money. Look at solar installations and realize that there's a lot of money up front to get them installed, but after that, it's just free energy. So there's a lot of different things that we can do, and we have to reduce our water consumption. So simple things like don't leave the water running when you're brushing your teeth, because many areas of this country are losing water. Chicago, we're kind of blessed to be on the Great Lakes, but as a general rule, that is also something that we can do. So I'd say as individuals, insulation, meat consumption, and recycling might be the best things that we can do as individuals besides voting. Next question.
Carol asks, can you comment on the destruction of the Amazon rainforest?
Oh gosh. That hurts me every time I learn what's going on there. Bolsonaro, the head of Brazil's government, is basically a huge climate denier, and he just wants to turn it all into farmland. He has no concept that the rainforests are the lungs of the earth. This is what absorbs, so trees absorb so much carbon, much more than any other plant type. And the trees there are enormous. And by cutting them down and then burning them. So it's not just cutting them down, but we're taking all the collected carbon in these trees and burning them and putting them immediately into the atmosphere, not even allowing them to rot. So it's an absolute tragedy. And it appears that the people of Brazil are onto this, and he's very unpopular now. And Lula, the politician that was jailed but now released because it was he was a kangaroo court there, and he's running a very strong campaign. And let's just keep our fingers crossed that the people of Brazil will save their rainforests. We have rainforests in Indonesia that are also in peril. The governments there are not supportive. Palm oil, just Google palm oil, and find out what's going on with the rainforest and the palm oil industries. It's just horrific what is happening to the lungs of our planet. So that's my comment. I'm very negative about it, obviously, and it makes me heartsick to think this what's going on. And then the thing is, when they cut them down, they don't grow back as jungles. They don't grow back as rainforests. It changes the land forever. So it's not like, oh, we'll just stop it and it'll all grow back in a few years. No, that's not what the rainforest does. And so our losses may be permanent. That's why we have to stop it now. So I'm sorry to be negative about that, but it's a huge loss.
Are there any other questions in the chat? I'll wait a few more minutes for people to type their questions in, but while you're still hanging out, I'm going to post a link to the survey here in the chat. So if you could just take a moment to click on that, it just gives us good feedback. And then if anybody else has any questions, please feel free to type those in the chat. And then, Kent, do you want to put your contact information back up there one more time? So if you do have further questions, he's encouraging you to go ahead and reach out to him, which is great.
And I and other people, Mr. Gore has trained over 15,000 of us worldwide, scores of them in the Chicago area. I give presentations all the time, and I do them for free. If you have a group, a club, a church, a school that may like to see a presentation that I do, please contact me and we can arrange that. And again, I don't charge anything for it. Mr. Gore doesn't allow that. All this has to be free to the public.
Okay, well, if there are no further questions, then I'll go ahead and let you guys go. I just want to say thanks again. Carol says, excellent thought-provoking program. I totally agree. This is a great way to spend my Earth Day evening thinking about an important topic. So thank you for your practical solutions at the end too. Really
We can do this.
We can.
It's happening. And watch what the president has to say today and tomorrow. Some significant goals promising to have our greenhouse gas emissions by 2050. A lot of people are saying that's not good enough, but I'll tell you, it's a good step. So watch this space, as we say. And thank you for showing up.
Thank you. All right, everybody, take care. Happy Earth Day. Thanks for joining us. Have a great night.
All right. Bye-bye.